Law of Parallelogram of Forces. Before we understand the law of parallelogram of forces, it is really quite important to understand resultant of two parallel forces. Resultant of two parallel forces. Now, to understand that, if we consider two parallel forces, one force is force P and other force, that is a force Q. Now, both the forces are acting along like direction, that means a similar direction. Then if we think of that, the effect of these two forces is the same as the single force, and that force that we denote with a capital R. So that force is generally known as a resultant force of that particular two forces P and Q. We can also write down that R is equal to P plus Q, right? Now here a force P and Q are a vector, hence the resultant force, that is also a vector. So the vectorial sum, if we write down in terms of force P and Q, so that is like this: vector P and vector Q. So definitely R is also a vector, and both the forces are in this direction, so R will be also in the same direction. Now if we consider a force Q and P, both are parallel but unlike forces. So again, if we draw a second system, so this first system is a like force, okay, like forces. Now we take a second system, so again we have a force number 1, that is P, and another force, that is force Q, little bit bigger than the P, but that is also in different direction. Okay, so we write down here, this is a unlike forces. Now we think of that, now what is the resultant of this P and Q force? So the resultant of the two forces P and Q in this case will be the arithmetical difference between the magnitudes of force P as well as force Q. Further, if we think of the direction of the resultant force R, so that will be the same as the direction of the greater of the force, and greater force is Q. So here just we take a arithmetical difference of this P and Q, so our R, that is like this, okay, and in the direction of the force Q, because Q is the greater one. Again we write down in a vector manner, so R is equal to P plus Q, right? So P is in this direction, Q is in this direction, and R is in the direction of Q. So this is the actual representation of like and unlike forces and its resultant. Now we understand law of parallelogram of forces. So this is generally used to find resultant of only two forces which are not parallel. And if you want to use or a system that consists of more than two forces, then it is used number of times. Suppose if we take a force P and force Q, that is act at a point O, and the angle between that two forces is nothing but alpha. So if we consider the force R, that is a resultant force of that force Q and force P. So if we draw or extend a line that connects the resultant R, so it is nothing but one type of a parallelogram. So this resultant R may be determined by the law of parallelogram of forces, and that law stated as that if two forces which act at a point be represented in magnitude and direction by the two adjacent sides of parallelogram, that is drawn by or drawn from one of its angular points. Then the diagonal passing through that angular point represents the resultant of above two forces, and that is also in terms of magnitude and direction. So this is a statement of law of parallelogram of forces. Now for the proof of that, for instance, if we consider force P, so let me draw one more figure here. So that represents force P, and second force that is drawn in this particular direction, that is force Q. So here that force P is represented by OA, and force Q is represented by OB. Now if we extend a line from point O and from point B, that is exactly parallel to the P, so from that connecting point O there will be a resultant of that force P and force Q, that is R. And here the angle between P and Q, let us we take as a theta here, and the resultant R, that will make a angle alpha with the force Q. So this is a geometrical property of parallelogram. Now, if we complete that parallelogram with point C, and after that also that is mentioned earlier, resultant of R, that is of force P and Q. So that is lying with OC here. Let we consider the point D, that is be the foot of the perpendicular that is drawn on line OB, and again we extend that line OB and that connects at point D. So here that angle between OA and OB is theta, so same way this angle is also theta. Now from the triangle OCD, this OCD, so we can write here, now from triangle OCD, OC square is equal to OD square plus DC square. Okay, this is this triangle we are going to take here, OC and D. Here something somewhere it is B. Now if we go further, that but our OD, this line OD is nothing but a portion of OB plus BD, so that we can write down here, that equals to OB plus BD. Right, now if we think of that, what is BD? So BD is nothing but, we can write down, because of this angle is theta, so that is nothing but a BC cos theta. So again further, OD is equal to OB plus BC cos theta. Now OB is what? That is Q, and BC cos theta, right? So BC cos theta, that is, if we take a BC is nothing but a same as the P, so BC is equal to P. So again further we just write down this equal to Q, so B is equal to Q plus BC is P, so P cos theta. So this is our new equation. So here we just denote, this is equation number 1 and this one is equation number 2. And further if we write, and our DC, this one DC, that equals to, if if BD is BC cos theta, so CD or the DC is BC sin theta. So this is BC sin theta. Again BC is equal to P, so that is P sin theta. So this is our equation number 3. Now putting value of equation 2 and 3 in equation 1, that is R square is equal to OC square is equal to, in bracket, Q plus P cos theta square plus P square sin square theta. Now if we further elaborate this, r square is equal to, now if we just open up it, that is q square plus 2pq cos theta plus p square cos square theta plus this term remains same, p square sin square theta. So again rearranging that equation, so q square plus we take this term 2pq cos theta plus p square common from this both the term, so remaining part, that is cos square theta plus sin square theta, but that we do not write here because we know that cos square theta plus sin square theta is equal to 1. So final equation we rewrite here by rearranging that, that is 2pq cos theta plus q square. So this is equation A. Now for the angle we just write down tan alpha, that is from the parallelogram, if we see, that will be dc by od. So if you do not remember, just I draw a parallelogram again. So parallel to that line A, C, B and O, so this is a force P, this is force Q, and foot from the C on extended OB, that is OD, here theta, here also theta, and this diagonal, that is R, that is with Q lambda angle. Okay, that is with Q alpha angle, right? So here DC, that tan alpha, if we see, so tan alpha is equal to, vertical line is DC and horizontal line is OD. Now if we want to put a value of DC, so that value is nothing but a P sin theta. DC is a P sin theta. If we take this P, so that is P sin theta that we proved earlier. Now what is OD? What is OD? So that is nothing but first is OB plus BD. Okay, so OB is nothing but a Q plus BD is P cos theta. Or you can write down alpha is equal to tan inverse P sin theta divided by Q plus P cos theta, bracket over, and that is equation of a alpha angle. Now other than that, if we take a very simple case over here, so that case is of forces that acting at a perpendicular to each other. Now in this case, if we see, P and Q are the force and that is applicable at perpendicular exactly a 90°, and if we want to find out the resultant of the same, right? So what happens, so theta is equal to 90 here, this is theta, that equals to 90. So again we want to write down this equation, but this cos term will not come, so r square is equal to p square plus q square. So this term will not written here because cos 90 that will be 0. So this term will be deleted. So this is the equation we can write down here with a small a to find out a resultant. And if we want to find out angle, so equation is tan alpha, that is very simple, p by q. So these are the equation that is generally used to find out magnitude of a resultant as well as the direction of the resultant. So this is all about law of parallelogram of forces.